Professor Sachin Gengaje, Professor and Head at the Department of Electronics Engineering at Walchand Institute of Technology, Solapur. Today, I'm going to present a brief review about Introduction to Machine Learning. We may have more parts on this introduction. So, in today, I'm going to present the first part of this Introduction to Machine Learning. The learning outcome of this session is after completing this session, after listening to this video, student will able to compare machine learning with the conventional computing algorithms. Now, everybody is talking about machine learning today. One can see many applications of machine learning. Is this machine learning a new technology? So, to get the answer of this, let us see a person called as a Thomas Bay, who was there more than 300 years back, and even today we are many of the models of the machine learning are based on what is called as the Bayes theorem. So machine learning is not at all new. The roots of machine learning can be located into statistics and mathematics, but in recently the machine learning has gained popularity. Algorithms of machine learning, they have gained popularity because of the vast data available and fast processors available. But just to tell you again, machine learning is not very new. It's the algorithms are quite old. What is a machine learning? The term machine learning was coined by Arthur Samuel in 1959, and what he was talking about machine learning is that it gives computers the ability to learn without being explicitly programmed. So that was what the definition of machine learning in 1959. And then in 1977, Tom Michel gave a well-posed mathematical and relational definition for machine learning. So even though that definition of Tom Michel, 1997 Tom Michel definition of machine learning, what is called as a well-posed problem, we are still using as far as this machine learning is concerned. So before we go to the machine learning, we should ask some of the fundamental questions like, do machines really learn? Now, if they are learning, and how they can learn, which problem can be considered as a well-posed learning problem, and what are the important features that are required to define a well-defined learning problem. Now, when we talk about machine learning, definitely the machine of which we are talking about is nothing but a computer. And then what machine learning is basically, these are the algorithms which we are running on the computer. So whenever someone says machine in machine learning, he or she is referring to computer and computer programming. So let us have a very formal definition of machine learning. As I say, a machine learning are nothing but the computer programs or computer algorithms. A computer program is said to learn from experience, called as a E, with respect to some class of task T. So it is expected that the computer program should solve some task T using the experience, which is nothing but past data. And then in order to measure the performance, there is some performance measure P, and if the performance at the task T, which is measured by P, if it improves with the experience, then it is called as the machine learning. Another interesting fact about machine learning, although we say that machine learning are the computer programs or computer algorithm, machine learning is an application that enables a system to learn and improve from experience without being explicitly programmed. So we are not writing any explicit program, but rather the machine learning algorithms are based on the data. If we want to compare the conventional programming and the machine learning application, I think that in case of, take an example of conventional programming in which we need to sort say 10 numbers. Now in that case, if I want to have a program, or I want to use computer to sort my array of 10 number, so input for that are by 10 numbers, and I give the algorithm. Maybe that algorithm is kind of a bubble sort algorithm, and then the output of my program is the calculated output y is equal to f of x. If my input data is x, if my algorithm like a bubble sort is f of x, then my output is the calculated output. My computer program gives me the sorted number. So I can say that y, which is an output, is computed by my algorithm, and the input used is my data. So that is how conventional programming application works. In case of machine learning, we have input. Of course, we do have a program, but these programs are different. These algorithms are different. What we provide to machine learning algorithm is the input data x and the output data. We don't explicitly program or tell how to calculate output based on the input. In case of conventional programming, we give input as well as the function which tells how to calculate the output based on the input. But in case of machine learning, we give the input and the desired output to the computer program. So the computer program or algorithm learns from the past examples, which consist of x, which is the input, as well as the desired output, and it gives the estimation of algorithm f dash, what may be the probable function which try to map the input into the output. So that is a very interesting difference between the conventional programming and machine learning algorithms. Now, although there is a lot of talk about the machine learning and many new applications are coming as far as the machine learning is concerned, when not to use machine learning. Before we understand when to use machine learning, let us understand when not to use machine learning. Machine learning is definitely not a solution for every type of the problem. Where in certain cases where the solution exists, we know the steps to calculate the output. We know the rules to calculate the output. For all such type of situations or application, the machine learning algorithm shall not be used. Say for example, I want to find out an hypotenuse of a right angle triangle, which is very easily can be calculated by the formula c is equal to square root of a square plus b square. Then in that case, machine learning should not be used, because that task can be solved using a very simple mathematics. Then I can write a program for that. Similarly, if there are certain rules, say for example, calculation of income tax, there are rules to calculate the income tax based on the different slabs of the income. Now in that case also, machine learning should not be used. You can do that using simple programming. Now when to use the machine learning then? Then whenever the application, for the application you cannot code the rules. Like many human tasks, such as recognizing whether an email is a spam or not spam, we do not have very straightforward rule, and then these kind of problems cannot be solved directly using the rules. A rule-based solution may not exist. Then in some of the application, a large number of factors could influence the answer or the output or the rules. Suppose there are 100 parameter on which the output may be depending. Then all and for all these kind of situation, where the rules may overlap or rules may require fine tuning, no mathematical direct formula exists. So for all that kind of application, the machine learning is being used. Actually, we humans are very good in solving these kind of problems. What can be example of the machine learning problem? Like recommending the product or medical diagnosis, segmentation of customer, then sentimental analysis. These kind of application may not have direct rules and which can be solved using machine learning application. Then we come to what is called as a well-posed problem. A machine learning problem is a well posed if solution to that problem exists and if that solution is unique and that solution depend on the data, and it is not sensitive, of course reasonably small change in the data or experience, then that kind of problems are called as a well posed problem which can be solved using machine learning. Not all problems are well posed problems. First we have to find out whether the problem is well posed problem or not, and which can be solved using machine learning. Now, what are the examples of the well posed problem? Say to filter emails as a spam or not spam. If you want to write a program for playing chess or handwriting recognition. Autonomous car driving can also be an example of well posed problem. Fruit quality classification. I'm taking the pictures of the fruits and then trying to classify it into good fruits or the fruits which are of not good quality. Face recognition for security application. All these are the examples of the well posed problem. See, for example, I'm trying to solve a problem like I have the data for the class for the student, and I'm trying to predict the university examination mark based on the roll number, height, and gender of the student. Now, this cannot be a well-posed problem because there do not exist any relationship between the marks scored by the student and his roll number, height, or the gender. So the mark are not depending on these parameters. So this problem not only by the machine learning, this problem cannot be solved by any other method also. So this is not a well posed problem. Similarly, if I'm taking a photograph at a traffic signal and trying to classify the vehicle, whether it is a two-wheeler or three-wheeler or four-wheeler, and the feature which I'm trying to use is the color of the vehicle, then of course this problem is not solvable and this is not a well posed problem. So before we take to solve or solve any problem or application, first we need to find out whether it's a well posed problem or not. Then let us have a question whether this problem is well posed or not, deciding the road signal timing based on the traffic density. So at a signal, again, I'm taking a picture or a photograph in real time and finding out how many vehicles are there, and then deciding for how much time the green light should be on so as all these vehicles can pass. So whether this problem is a well posed problem or not. And then second question is, shall we use the machine learning for preparing the merit list of the college? So we are for the admission, we are preparing a merit list of the college, and then whether we should use machine learning application for this preparation of merit list. So think on these two questions. So with that, we come to the end of the first session on introduction to machine learning. These are the references. I have used two references. Of course, the machine learning by Tom Mischel is a classic book. So, and then there is another book on machine learning by Pearson. So thank you very much for joining today's session, and see you in next lecture. Thanks again.